You did. You can go with you guys. Did you do this? Okay. The ball, yeah, it's obvious. Ah, you're small for a sixth grader. All right. Oh, okay, here you are. Ball. You already did it. Well, okay, here you go. Yeah. It's not your option. You have to do it. You're in the room. Okay. I didn't ask you guys. I did. Okay, once more. It's time to start. Okay, first of all, I'm Mr. L, and my colleague here is Mr. K. L is for Leonardo, and K is for Kawamoto, but our students just call us Mr. L and Mr. K. We'll leave here that way. Between us, we're both retired, and between us we have well over 60 years of teaching physics, explaining this stuff. We're going to suspend that today, but that's our experience. We did not do this show last year, but here we are, welcoming you to the 26th Onizuka Science Day and about the 15th of our show. First, I want to thank everyone in here for actually coming, for actually attending. It isn't often that such a large group of people will give up a beautiful day to voluntarily take a physics exam. And we do appreciate that. Now, there are some rules. Rule number 1 is everyone in the room must participate. That means everyone in the room has got to take a shot at an answer. We're going to do a kind of a path demonstration. We're going to ask you what you think the outcome is, and you're going to tell us what you think the outcome is by holding up a card. Everyone in the room has got to hold up a card. If you don't hold up a card, or you can see now that you don't want to do that, then now is the time to leave. But you'll enjoy it if you stay. Okay. Next, no questions are allowed, and no explanations will be offered. If you think that's hard for you, and it usually is, it's much harder for us. We've spent, between us, something like 60, 70 years explaining this stuff, and we're going to put that on hold for the next 45 minutes. No questions, no explanations. But you can stay after and ask questions then. No cell phones, iPhones, iPads, or any other kind of pads in use during the show. So if you have those, please turn them on. Okay, now, you all have a quiz, a green quiz in front of you. There are 21 questions on the quiz. I'll be back in a half an hour. The shark will be watching you. Oh well, that didn't work. Yeah. Okay. Anyways, if you want to score yourself, the suggested scoring is this. If you get 12 or more right, then you might want to consider physics or engineering as a major. If you get 6 through 11 right, then you might want to consider English, math, music, history, psychology, any number of other perfectly honorable majors. If you get less than 6, then very high on your list of possible majors should be chemistry, followed by business and political science. Any discipline in which the ability to make a reasoned prediction from a few basic principles is not required. I would at this point say, are there any questions? But that refers us back to Rule 2, which says, no questions. So we'll begin. First one is question number 1. Spool. This is a spool. There's no tricks involved with this at all. It's ordinary. Incidentally, throughout all of this, there are no tricks. There's no hidden deception. It's all just basic physics. I'm winding the string this way, and I'm placing it on the table. I'm going to pull the rope. Watch which way it goes. But of course, that's not the question. The question is this. If I take it and turn it upside down, so now the string is coming off the bottom. If I pull it to the right, to my right, the spool will A, move in the same direction in which I pulled it. So A, if you think it goes this way. B, it moves in the opposite direction, that way. C, it just slides along. So A, this way, B, this way, C, it slides along. A, this way, B, here, and slides along. Everyone has to have a card out. Look at that, everyone has a card out. How exciting is that? Yeah. And it's almost all B's. Yeah. Okay, very good. Let's see what happens.
Watch it, please. Yes, please.
Here we go. Wait a minute. Can that really be?
Yes, it is B. Okay. Now, this is something a little more practical, a mode of transportation that many of you have used recently. And if I take and do something similar by pulling this to your right, it moves to your right. But most of you, when you use it, you use the pedals here. And if I pull this pedal to the right, it moves to the right. But the question, to get you to think, is suppose this pedal is down here at the bottom, and I pull it to your right. Question is, does it move in the same direction that I'm pulling to your right? Or B, it's going to move backward.
A, this way.
Forward.
B, backward. A, forward, B, backwards.
When I start pulling on this chain.
Everyone's got to take a shot at it here. A, forward, B, backwards. A, forwards. Everyone's got to have a card up. Everyone has a card up. Okay, let's see what it does. It looks like it's about E. It looks like the A's have it.
Yeah, maybe the A's have it. So it's going to move forward. This watch.
And it does. Number 3. For number 3, we're going to take and add ice cubes to an ordinary, well, it's not so ordinary glass of water. I suppose a chemist might drink out of a graduated cylinder. Okay, and the question is, what happens to the level of water in the glass as the ice melts? So I want you to verify that the rubber band is at the top of the liquid water. Okay, all right. So as the ice cubes melt, the liquid water will A, increase, B, decrease, C, stay the same. A, if you think the level is going to go up, B, if you think it's going to go down, C, if you think it's going to stay the same. Okay, we have A, gosh, it's like a rainbow, all about the same. A, B's, and C's. Okay, let's see what happens.
That's amazing.
We'll put it off to the side.
And come back later. Okay, this is one that you might be familiar with. The 2 balloons, and I have a valve here that will actually allow me to connect these 2 balloons to each other. And the question is, when I do connect them to each other, does the small balloon get bigger? A, it gets bigger. Or B, the small balloon gets smaller when connected. So what happens to the small balloon? Does it A, get bigger? B, get smaller?
When you connect the 2 together, does the small balloon get bigger? A. Does it get smaller? That's B. There should be no C's.
Yeah, because you don't have a choice.
A gets bigger, B gets smaller.
everyone have a card?
Yeah, looks like the A's have it.
Looks like the A's have it. So you should see the blue balloon getting bigger.
As the air rushes into the blue balloon.
And
There it goes.
there it goes, and you can see it getting small.
Next one. Next one is on the next page. Next page. Number 5. Cart with rubber bands. Okay, these two carts are identical in mass. They're connected by a rubber band. I'm going to pull them apart, let them go at exactly the same time, and watch what happens when they hit. They stop. One more time. They stop. But that's not the question. The question is this. If I now take one of the cards and I double its mass, so now this card is twice as heavy as the other card, and I again pull them apart and I let them go at exactly the same time, will they, A, again, just stop, B, continue to go in the direction of the more massive cart, that's this way, or go in the direction of the less massive cart, that's this way. So, A, if you think they're going to come to a stop again, B, if you think they're going to go in the direction of the more massive cart, C, if you think they're going to go in the opposite, in that direction. So we have a few A's,
Mostly B's.
mostly B's, to go in the direction of the more massive cart. Yeah. Okay, here we go. 1, 2, 3. What do you do?
Maybe if we wait long enough.
Stop.
Okay, this one here is a race between different objects. We have a ring and a disc, and they're made to be very close to the same mass, both about 500 grams. And they also have the same diameter and very nearly the same thickness. So they have the same properties. And the question is, when I release these down an inclined plane, which one hits the bottom first? The solid wooden disc, A, B, the ring, C, they'll hit at the same time because they have similar properties. So A, the solid wooden disc, B, the ring, C, at the same time. It looks like, it's hard to tell, but
It's a rainbow.
yeah, it's a rainbow.
Yeah.
Okay, this is the thing to do, is just watch and see. 3, 2, 1.
Go! Go! Go!
Looks like a wooden disc. Okay, here I have a heavier wooden disc and a light wooden disc. And the question is, which one of these will hit the bottom first? The heavy disc or the light disc? Heavy disc, light disc. And you don't have to, there's no
Yeah,
letters.
there's not, this is not a quiz.
Okay, so this one you just watch, and so you can determine.
Wow.
The light disc seems to be faster. Okay, this one does have a trick.
Yeah, that is.
Weighted this.
Okay, next one is number 7, the soup can race. And unfortunately, I can't put all on the. Oh, maybe no, I can't put them all on at the same time.
My sons are here.
Oh, then you need cards.
Oh, I'll get them.
There's an extra set here.
Thank you.
Okay, have a seat. There's one right there. Right here. Look at that, right in front. Oh, it only has what you need. Okay, we saw already that the disc was the champion between the disc and the ring. And we're going to compare now the disc. All this one I'm doing right now is preliminary. I'm going to compare the disc with Paramount hot beef tamales with sauce. And that's just no question here. Looks like the disc barely has it, maybe? Let's see. Same time. So we'll have the beef tamales and the disc are essentially the same. Now we're going to do the beef tamales and chicken noodle soup. 1, 2, 3. And the beef tamales has it. And now the question. We have beef tamales versus chicken broth. Campbell's great for cooking chicken broth. A, if you think the beef tamales are going to get to the bottom first. B, if you think chicken broth is going to get to the bottom first. And there is no C. So A, forget the C, yeah, forget the disc. Beef tamales, chicken, oh my God, not me.
What was that?
Shut up. Yeah, beef tamales is A, chicken broth is B. Did I have that right? Yes. Okay, ready? Looks like we're about even. Okay. 1, 2, 3. Whoa! Look at that. Nothing is faster than Campbell's chicken broth.
I had the 6
Okay, so this next one is a race between a couple of meter sticks. This one here is just an empty meter stick, a regular meter stick, and it's going to fall like that. Here we have another meter stick that's almost identical to the first one, except it has a 1 kilogram mass taped to the end. And the question is, which one will hit the ground first, or the table first? And the orders are A, the stick without the mass on the end, B, the heavier stick will hit first, or C, they strike the table at the same time. So A, if you think this one will hit first, B, the heavy mass, C, same time.
Okay, stick without the mass is A. A is the stick without the mass hitting first. B
is the one with the heavy mass at the end. And C is the same time.
Okay, looks like, yeah, B, yeah,
So
makes
you
sense.
think the heavy mass is
on
going
the
to
end.
hit. So you can watch it hit first.
Which one hit first?
Block.
A. The light one. A little bit ahead.
It was the light one.
I had it.
You have it? You're a genius.
Yeah, we
Huh?
Okay, this one is item number 9. I have the mass with the mass on the end of the meter stick. And what I'm going to do is hold it off to one side like this, and then we'll let it go. Just all of a sudden I'm going to release it. Just instantly let it go. And the question is, when I release it, what is the orientation in which it falls? If you think when I let it go it's going to fall this way, in the same orientation in which I let it go. In other words, I let it go and it falls just like that. That would be A. If you think when I let it go, and hold it like this and let it go, it does this, it falls with the heavy side first, that would be B. And C is if I let it go, it does this. The heavy side stays behind, it does that. So A, this way,
Stays flat.
B, this way, C, this way. Get your cards up, this is hard to hold. Okay, B, A, C.
More B's.
Okay, here we go.
So the heavy one's going to
Here
go
we go.
down first.
1, 2, 3. Oh, you have to watch. What does it do? 1, 2, 3. Oh, I missed. But you should have seen it falls this way. The answer is A.
Until we grab it. Now, this next one is something that you've probably seen in the movies. There's an action figure or action hero that uses this a lot. He gets stuck in the middle of a lake with no wind, and he finds a fan and blows the fan into the sail, and the boat just takes off. And you can see it just taking off like that. Okay. How did he do that, Mr. Mickey Mouse? Okay, now, that's not the question though. The question is, I'm going to have the fan going again, and I'm going to put a piece of cardboard here so that the wind does not hit the sail. And if I block the wind from the sail, what happens? It, A, remains at rest because the cardboard's not touching anything. I'm not going to let it touch it. B, it moves forward to your right now. Okay. Or C, it's going to move back to your left. So A, it stays there. B, it moves forward. C, it moves backward when I block the sail. See those words? A, B, or C.
Forwards, backwards, or it stays put. A, B, or C.
Okay. Looks like it's a rainbow.
Yeah.
There may be a little too more C's.
Yeah.
So watch what happens.
Okay, let's see.
Foggy.
Yours isn't right either, Ian.
Yeah. Just to the left.
Yeah, you're right.
Going now to number 11.
I have said
Okay, for number 11, the first part here is preliminaries. I'm going to take a very 1 kilogram mass and an ordinary sheet of paper and drop them simultaneously. Watch which one hits the table first. Yeah, the mass is first, right? But that's not the question. Here's the question. I'm going to now crumple the paper, making it a lot heavier. No. Crumple the paper up, and then drop the two again at the same time. Which one hits the table first? A, the heavier mass still hits the table first. B, the paper actually hits the table first. C, they hit the table at the same time. A, mass. B, paper. C, same time. You got it. B's and C's with a smattering of A's.
Yeah.
Okay, let's see what happens. 1, 2, 3.
Oh, paper.
Which one hit first?
paper.
Oh, watch. Same time.
I got it.
I saw paper.
Next demo is how many of these flasks, which are filled with water, include food coloring, will it take to fill this this flask or this cylinder up to the yellow ring? Will it take one of these to fill it all the way up to here, 2 of these to fill it all the way up there, or all 3 of these flasks to fill it up to the yellow ring? So A, it'll only take 1. B, it's going to take 2. C, it's going to take all 3 to fill it. We need some cards. I don't know if you guys can all see the size of the flask.
Yeah, we have 3 of
3 of these flasks.
How many of these flasks will it take to fill that cylinder? 1, 2, or 3. A, B, or C.
It looks like scattered. A lot of A's and B's.
You see.
Yeah, and 2 C's. So let's just start.
Let's just see what
how many it's going to take.
And if we need, I can fill up some others.
Yeah, we can get some more if we need it. Okay, so let's start with the first one first. Then we'll move on to the second and the third. It takes 1.
What happened to the very top?
Sit to the ring.
Number 13. What I have here is a fan, a frosty air 8-inch fan, and an ordinary balloon. This is not helium filled, just an ordinary 12-inch balloon. And what I'm going to do is I'm going to place the balloon in the motion, the air of the fan. And there are three possible things that can happen. One, when I let the balloon go, the balloon will just fall down. Fall down here. Two, or B, it will fly away and then fall down. Or C, it will just stay there when I let it go. So A, it drops into the sink. B, it flies away, it falls over there. And C, it just stays put. Let's get hard out, hard out. Okay, so A, it falls straight down. B, it falls over here, hits the ground. And C, it stays there. We have three possibilities. A, it falls straight down. B, it flies over here and hits the ground. Or C, it stays there. Now, I'm really hoping to see a lot of C's.
I got 6 right now.
This next one is we have a scale here that will measure weight, and we have a 1 kilogram mass, and the weight of a 1 kilogram mass is about 10 newtons. And you can see it reads about 10. Here I have a pulley, and a pulley just changes the direction. It doesn't change the magnitude. So you can see that if I hang it over the pulley, it still reads about 10. Now, I have another mass, 1 kilogram mass again. If I put it on this side, it's going to jump up to 20. Now, what I'm going to do is there's another string attached to this on the other side. So I'm going to put this mass here, but nothing's going to happen because there's an aluminum pin right here, preventing anything from moving. Now the question is, when I remove this pin, what's going to happen to that reading? Oh, sorry, it doesn't matter. Is what happens to the reading is the scale is going to go to 0 when this pin is removed. B, the scale is going to double because there's 2 masses. C, the scale reading remains unchanged when this pin is removed. So A, it's going to go to 0. B, it's going to double. C, it remains unchanged. A, B, or C.
0,
A, 0, double, unchanged. It looks like A's and B's mainly. Okay, now what I'm going to do is I'm going to hang on to this washer right here and slowly remove the pin, but I have a good grip on this washer. Okay, now, when I release this, you can see what happens. 3, 2, 1, release. Yes. Oh, did you see that?
Okay, this is number 15. These are 2 ordinary, no tricks, just cheap bike tires that I'm going to now spin in opposite directions. And then let it go. When I let it go, it's going to fall. Yeah, big deal, right? That's what you expect. Right? You want to see it again? You do? Yeah, okay. Look at they're so quiet.
Yeah.
Amazed. Here you go, watch. Ooh. All right. But that's not the question. The question is, if I now take these 2 tires and spin them in the same direction instead of in opposite directions, will they A, fall faster than they did before, you know, really fast down, or very slowly, or about the same? Or about the same, yes. So they fall faster, very slowly, or about the same. A, B, or C. Faster, very slowly, or about the same. Faster, very slowly, or about the same.
No.
All right, here we go. Ready?
Oh my God.
Ah, come on! It won't fall. But if we wait long enough, it'll see it's starting to fall. Very, very, very slowly. know why you press the button.
Okay, now this next one is the energy ball that I have seen before. Let me hold this up for a second. If I pull one ball out and let go, when it hits, one ball goes out. If you pull two balls out and let go, two balls go out. The question is, suppose I decided to pull three balls out, is how many balls go out? Because there's only two sitting there. And so the possibilities are three balls still go out, or B, one ball goes out, but it goes very, very fast. Or C, all five of the balls go out. And you have this three ball collision. And I have to do it down here on the table, because when I hold it, it starts to move. So I'm going to pull three balls back, and those up front can verify those people in the back. See how many balls go out. How many was that? Three. Now, some of you may have had a little trouble seeing this. So we decided to build a bigger demo. And off to the left side where Mr. L is located, he's got a bigger demo up there. That's a little easier to see.
One. Two. And what's going to happen? Three. How about five? Whoops. Okay. When you take Physics 1A, you'll get to see what happens when this guy hits them. And it's a surprise.
That's why he has that nice happy face up there.
Oh, what's next? Okay, yeah. What's this stuff? Okay, did everybody in the room, oh, you came in late. Okay, which is heavy? Yeah. No. Yeah.
Yeah, you can do it.
Did your question is one heavier?
Did everybody try this?
To see which one is heavier.
No. You get one shot at it. Okay, let's see. I think there was one. You didn't?
That way you can get the right answer. Hold up the right card.
Steel ball. Did you?
Anybody else? So that you'll all be able to choose your answer.
Okay. So, everyone in the room. I think there might have been one person who disagreed, said that the steel ball was heaviest. So, really, there's no reason to even measure them, is there?
And since the majority picked the steel ball, why do the experiment?
I don't know. What do you think? Should we?
And that. We can go on. Let's just go ahead and
Yeah, look
see.
how heavy that steel ball is.
And then with the wood on there, you can see what happens.
No. Let's try that again. It could be that I've got this.
Yeah, that happens. Maybe this side is heavier. And so now this can go
Yeah.
on. Oops.
You used the right word. Here's
Oh, no, I need the scale. Now this needs to balance. Involves a quart of liquid. And here we have a quart of water. And here we have a quart of 40-weight motor oil. And the question is, which one of these two is heavier? A, the oil is heavier. You can see how thick it looks. B, the water is heavier. And C, they have the same weight because a quart is a quart. Right? Okay, so A, the oil is heavier. B, the water is heavier. B, C, same. So A for the oil, B for the water. It looks like mostly B's. So we can just try that. Put the water on this side and watch what happens when I put the oil on.
Yeah,
Either side.
All right, this next one, number 19, is kind of complicated. So we'll do it anyway. What what I have on the side of the room here is a ramp, that aluminum ramp. And I'm going to release a ball at the very end of the ramp. When I release the ball, there's going to be these two timers. Two timers start at 0. When I release the ball, the two timers start to count. When the ball gets 1/4 of the way down, that timer will stop. When the ball gets all the way down, that timer will stop. So that timer tells us how long it takes to go 1/4 of the way. That timer tells us how long it takes to go 4/4, or all of the way down the ramp. Okay, I'm going to read to you from the quiz sheet. A ball rolls freely down a 20-foot long ramp. If it takes about 4 seconds to go 1/4 of the way down the ramp, how many seconds will it take to roll all the way, 4/4 of the way down the ramp? You have three options. A, 16 seconds. Since it's 4 times the length, it should maybe take 4 times as long. That's A. B, 12 seconds. Since that distance is 3 times that distance, it should take 3 times 4, or 12 seconds. C, 8 seconds. Well, I don't know where we get the 8 from, but 8 seconds. So A, if you think 16 seconds. B, if you think 12 seconds. C, if you think 8 seconds. We have B's, C's, no A's.
It's like mainly B's and C's, and more C's. Yeah. So here it goes.
Here we go. Start. Oh no! So I'll tell them.
Okay.
Oh, I thought that was supposed to happen.
Answer to
Start. Oh no!
Oh, the ball's not going.
Okay, here we'll do this. We'll do this by hand. You tell me when you push this.
Oh, okay. Ready?
Yeah.
3, 2, 1, go.
Oh yeah! Oh yeah! Run, right. It's so cool.
Okay, next is number 20. Number 20 is shoot Crazy Chicken. But Crazy Chicken has left us. He's been shot. So,
A volunteer.
yes, I happen to have a little bear that my sister actually gave me about 20 years ago when I learned how to fly an airplane. And it's a little flying bear, and he will serve as our target. We're going to place him right where we expect the ball to shoot when it is shot at 30 degrees. So I'm going to read to you here from him. It says, shoot Crazy Bear. Place the bear so it is hit by the ball, shot at an angle of 30 degrees. So,
Which is about like
keep
this.
your eye on that.
There it goes. 3, 2.
Boom. Okay, it hit him. Didn't quite knock him over, but it hit him.
Yeah.
You agree that it hit him?
Hit them all.
Yeah, okay, good. Okay, so now what we're going to do is shoot the same gun, but instead of 30 degrees, which is this angle, we're going to shoot it at 60 degrees, this angle, much steeper. And the question is, if I shoot it at 60 degrees, will it A, fly over the chicken's head, hit the ground over here someplace, or still hit the chicken? A, fly over the bear's head, or B, still hit the bear? There is no C. Wow, look at this. It's almost unanimous.
Yeah.
But don't you understand? It's going to be shot at a much steeper angle.
Like this instead of like this.
Yeah.
It was like this.
I can't talk him out of it. All
There
right,
it goes.
shoot.
3, 2, 1.
Oh.
Oh no! You missed. He's in the right spot. One more shot. water question. We can now look at it because all the hot air that's been spewed in here, the ice has melted. So is the level the same?
Yeah.
Did you check it? Yeah. So the level stays the same. The level stays the same. Okay, now we have a number of no quizzes, just a bunch of quick little demonstrations for the next few minutes. I know you've got to get out of here. That's right, this is over now, isn't it? Well, stay as long as you like. We'll do a few other quick demonstrations and that's it. Let's see. Here. Hold on this. Oh.
Doing that, I think I'll start this one, is I'm going to drop the cylinder through this tube, and you can see how quickly I can move my hands down there to catch it. Now the question is, could I drop it in there, make one complete turn, and still catch it? Or will it be too slow? Will I be too slow? Okay, so let me just try this. 3, 2, 1, go. Practice.
Okay. Pull. Come on, pull. Pull. Okay. All right. Pull.
You look strong.
Now pull. Pull. Okay, now relax. Just pull it. Actually, no. Pull gently.
Okay.
Just gently.
You look strong.
And be really quiet. Shh, shh, shh. Listen.
Wow.
You really set your pressure.
Oh, yes. Who's? I need somebody here who's
Strong.
You think so, huh? Okay. See if you can pick this straight up off the table. Straight up. No, straight up. Pick it up. Come on.
Move one of the edges.
You can use that to make yourself a ninja wall walker.
Oh, yeah, that. Yeah.
Yeah.
You should do this. Okay, I have here a funnel and a ping pong ball and compressed air. There's definitely air coming out of this. And even if I put it in here, there's still, can you verify that there's air coming out? Feel it? Good. Okay. All right. Now, I'm going to put the ping pong ball in here. And hold your arms because it's pretty fast. And if it goes over your head, will you catch the ball?
Yes.
Okay. I won't go past you. Okay, you ready? 1, 2, 3.
Wow, that was quick.
Whoa. Give me that ping pong ball. You missed it. What in the world? How can that be?
Okay, this is my little noise maker.
You have a container to collect the
And
sound?
if it's too loud, you can pour some of the noise out. There you go. So I've got it all caught in here. Let me pour some back in.
Well, it smells some. Oh, you spilled a lot. Okay, yeah. Wood floats. So we have a container here. Where is it? Oh, there it is. A container of wood. Show you that wood floats. And rock sink.
As you can see.
And Diet Coke. And regular Coke.
140 calories.
That's why I give you that feeling. And I guess that's it. I'm going to read to you now from the bottom part of this. It says, ping pong cannon, firecrackers, falling monkeys, boil water to freeze it, exploding wine glasses, electron beams, rainbows, and so much more, complete with explanations when you take a course in physics at El Camino College. And I'm going to add, for a lot less money than you would spend to have a much larger class with 300 kids in it at one of those other places that will go unnamed. Thank you for coming. And feel free to hang around. Feel free to hang around and ask questions or whatever you like.
Oh yes, you can keep the green sheet.
Oh yeah, keep the green sheet. Yeah,
They're large pieces.
That's right.
Reusable.
That's right.